Hello, and thank you for sticking with us this afternoon. It's been a great Congress so far, and lots more content to go. So I just got the latest numbers from Fira, and you are among 5,500 people who are with us again. So people keep coming in the doors here, and really delighted to see everyone. For those of you who weren't in previous sessions, I am Lynn Canavan, and I am the Vice President of Programs for the Industrial Internet Consortium. And it gives me a huge amount of pleasure to introduce the next speaker from Microsoft. I think we've talked all through this Congress that, this is not your teenager's IoT. This is not consumer IoT. This is absolutely industrial IoT. Microsoft has joined the Industrial Internet Consortium shortly after we formed and has been a very, very active participant in all of our working groups and so forth. And it is with huge pleasure that I introduce Steve Teixeira, who leads Microsoft's IoT team and its vision. Welcome, Steve.
Thank you, Lynn. Thank you. I'd like to start off just to show you a quick video of some of the work that we've been doing with partners. Just about a minute. It'll be kind of fun, cool music. If you want to stand up and dance while the music's playing, I completely understand. It's a long conference.
We've been there, powering devices for 20 years, making the difficult look easy, and keeping life simple, taking you away and guiding you home, providing care and bringing new life into the world. Opportunity is all around us.
Thank you. Again, my name's Steve Teixeira. My day job is I work on Windows IoT. So my team and I are responsible for designing and building the versions of Windows that power all these devices that are not PCs and laptops and phones and tablets and traditional computing devices. One of the things I wanted to talk to you about today is, tying it back to this video. What you saw is about 2 decades of work that we've done with our partners and our customers to really bring IoT, the industrial IoT, to reality. And we've kind of gone on this journey with our customers from what you might call traditional closed or deeply embedded systems to connected embedded systems to intelligent systems to what we're today calling IoT. And got me thinking about, okay, well, how should we think about what is IoT? And what has made it different? Obviously, many of us have been in this space for a really long time, but something's changed, something's different. And there have been a couple things that kind of give me pause and cause me to think about what's been different. One of the things that's different is the pervasiveness of connectivity. Connectivity is so much easier, it's cheaper, and it's higher bandwidth. It's easier than ever to connect devices. A lot of that is enabled by the massive infrastructure of the cloud. The other thing that's changed is it's really easy to build devices. Now, I say that it's really easy to build devices while my colleagues, Tony and Zach, are here making sure that our device that we're building is actually working. And we've got some last-minute network issues. So we're going to let them make it work. And it's going to be super awesome by the time we get to this point in the presentation. But easier than ever to build devices. And in some ways, you can kind of think that, wow, it seems like the asymptotic cost is approaching zero of marginal cost of producing new hardware. It just seems to be getting more and more easy, cheaper and cheaper, driven by Moore's Law, driven by manufacturing, lots of forces that are at play really driving IoT. And so when we think about IoT, a lot of us focus on the things. The things are, it's the T in IoT. Things are important. At the same time, things are not everything. And I'd like to start by just kind of framing up how I think about IoT. And I think about it first, yes, as these things, and these things that generate data and that connect to other things. But these things exist within environments. So things are not standalone. They must work together to some purpose in certain environments, and they must work together for the service of people. Now, with this as the framing, I think about data and analytics as sort of the lifeblood. If this is the IoT organism, then data and analytics are the lifeblood of this organism. And then saying a little bit more about people, I see two different groups of people in service of IoT. There's kind of the people that you might think of are on the pointy end of the spear for IoT. They're the ones that are being acted upon by IoT devices, motion sensors, cameras. I'm the subject of an IoT device. At the same time, there's another group of people who IoT serves, and that's the people kind of behind the scenes, behind the cameras. Who are the people that are managing the NOCs? Who are the people making business decisions based on data coming off of these devices? Now, as I was preparing for this presentation, I'm in the shower, I'm washing my hair, and I'm thinking about, okay, how should I structure this presentation? And one of the things that got me thinking is, I wanted to think about, where did IoT start? Like, what was the first IoT solution? I'll ask you, shout it out. What was the first IoT solution? Anyone? Some phones. Phones are a good idea. Yeah, phones are a good initiative. So here's what I came up with. And you can agree with me or not, but what I came up with was, I think the Apollo space program was actually the first IoT solution. If you think about it, like this whole effort of sending folks into space, like, wow, were there things? There were lots of things, and they were really expensive things. This is a Saturn V rocket that you see behind me. This was the rocket that actually lifted astronauts off of Earth, sent them on their way to their moon, and for its time, it was probably the most heavily instrumented machine in the history of humanity. Every valve, every communication channel, every navigational aid, everything was instrumented. All that instrumentation was flowing back to mission control or launch control so that experts could make decisions based on the data coming off of those devices. And wow, were there experts in mission control? The photograph that you see on the left, that's actually a photograph not of mission control in Houston, but of launch control in Florida. These were the folks that were, propulsion, go for launch, and this subsystem, go for launch. These are the ones that were actually monitoring all the subsystems and monitoring the launch to make sure that a rocket could indeed get off the ground safely. Basically, the way you did, data analytics back then is you hired all the world's PhDs and you put them in a room and you gave them reams and reams of data, and then they would analyze this data using their slide rules, and they would come to conclusions, and then they would physically raise a flag and throw real exceptions, real life exceptions when things didn't go well. And finally, environments. Again, environments in IoT drive, how do things need to relate to one another in service of people? How do people need to relate to one another in these IoT environments? What do my machines need to look like? What is the difference between an urgent event and a non-urgent event on a device? And how do I deal with that given the environment? So lots of really interesting analogies that I've seen between the Apollo space program and then what's going on in IoT. And thinking about this idea a little bit further, I started making a list. I started listing like, okay, how did they build this solution? Like, what were the things they did around people and things and environments to build out this solution? And I kind of came up with this list. So we've got spacecraft. Like you saw the big Saturn V rocket. They had to get that spacecraft built. And that picture of the rocket, there's actually probably close to half a dozen different spacecrafts, right? There are 3 stages to the rocket. There's a lunar excursion module, there's a command module, there's a capsule. So lots of different spacecraft built into this thing. Life support gear, space suits, and CO2 scrubbers, and all this different gear that they've built in order to sustain life in this foreign environment. And then all the support vehicles that they built to manage the launch, the gantry, the big tank tractor thing that comes in and pulls the rocket onto the launch pad, the vehicle that sends the astronauts in their little bubble to the, to get into the capsule. Lots of physical things that they've built, which I think make up the devices. Like, these are the things in IoT as a part of the Apollo space program. And at the same time, a bunch of other things. We talked about the domain experts, these data science people that did the analytics, that were, today we might call these guys data scientists, but back then we might have called them hydrologists or meteorologists or whatever, and they literally used pen and paper and slide rules. I would say Excel and Power BI is probably a little bit easier today, and it's cheaper than a room full of PhDs, but this worked too. This was one way to, a different way to skin the cat. They had this computer that was way ahead of its time that they built that was a navigational computer. I'm wearing a Microsoft Band. It had about 2 orders of magnitude less computing capability than my Microsoft Band with its little Cortex M4 processor and 64 megabytes of RAM. But it did its job, and it did its job well in terms of gathering navigational telemetry and being able to steer on the path to the moon. And then all these modes of data acquisition, depending on if you're near field, far field, what kind of antenna do I use, how much bandwidth do I have, how do I prioritize the use of my bandwidth across all the different telemetry channels that I have. And really, I think you can boil all that down to analytics. They had to build a bunch of things that boil down to data and analytics. And then finally, wow, training, long, years-long training program and logistics. How do we do everything from buying pencils and paper to feeding everybody? Radio relays. In fact, they built what you might call the data centers of their era. They built a worldwide network of radio relays so that as vehicles were orbiting the planet, they were always within eyesight, line of sight, to a radio relay so that they could talk to people back on the Earth. So global network, of data centers, if you will, and then just dozens of facilities and operational things that go on and on and on, across the world. And I think about all of these things as, just the core infrastructure of IoT. We had to build all of this infrastructure in order to get someone off the, a group of folks off the planet onto the moon. So looking at this, now I started reflecting on, okay, well, what does this mean for us? Like, how do we get to the moon? How do all of us get there? And I think we can look at the world through the same kind of lens as we look at the Apollo mission. Well, certainly there are devices, and I would talk about those devices probably a little bit differently than I would talk about the devices in the Apollo program. I think, I've sat in on a few presentations, and I don't think I've seen a presentation yet where I haven't heard the word security mentioned at least 80 or 90 times, during the course of the presentation. It's obviously top of mind for all of us as we think about building industrial scale or consumer scale IoT solutions for that matter. Even if we just look into the consumer space, we see, either potential or actual security problems, whether it's automobiles or baby monitors or Wi-Fi routers or what have you. In some cases, capital infrastructure. So being able to build devices that are inherently secure, and of course security, sometimes I meet with customers that are building these IoT solutions, and it's nobody in this room, so we'll start there. Like, everybody in this room is cool. But some other people that I've talked to will say, yeah, my IoT system is really secure. I'm using SSL between the device and the server, so I'm secure, right? And so going through this process of kind of educating, well, security is a little bit more than just privacy over, a point-to-point network connection. Security starts at making sure that devices can boot securely, and what is stored on the device stays private, and any personally identifiable information stays private as appropriate. There's a lot more there than kind of maybe meets the eye. And then what is the human-machine interface? We talk about IoT as kind of devices ranging from the simplest devices, little sensors that read temperature or read pressure or read motion, and ranging all the way up. And I think that's totally true. I think sometimes we underplay the need for actually very capable devices at the leaf nodes of IoT solutions. HMI is one of those examples where increasingly we expect to interact with our world through voice, through gesture, through touch. And you need a pretty capable computer at the end of the day in order to interact with it that way. Certainly, gesture and touch, you're not necessarily going to relay everything back to some big brain in the sky and back down to the device again. It's kind of funny. I think if you look at our industry, perhaps every 10 years we go through this thing where we think, these client devices, pretty soon they're all just going to be dumb thing clients because the X is taking over what's happening on the client. And depending on the era you grow up in, feel free to replace X with the mainframe, the Unix server, the web, the cloud. We always talk about how some massive computing thing that's remote is going to take away the need to interact with devices. And I think what reality is borne out is it's quite the opposite. We actually see both centralized, massive scale computing growing at an enormous rate, but we also see the need for high compute capability, high storage capacity, highly capable computers at the leaf nodes, and that is growing at an enormous rate as well. So we see both of these things happening, which I find interesting. And of course, devices need to be connected, connected by default, not just connected to some service, but connected to one another. And that speaks to the importance of, gosh, can we get together and agree on some set of protocols that we might want to use to be able to interconnect devices or connect devices to services? Can we agree on some security principles that we might want to use to enable devices to securely participate in that ecosystem? Then if I look at analytics, I think one of the perhaps undervalued spaces in analytics is this idea of data ingestion. We all think about, yes, these devices are generating data, and this data is going up to the cloud. But usually when I see partners, customers building out solutions, this notion of data ingestion starts very simple. I know I'm going to build a web service, and I'm going to set up a REST endpoint, and my device is going to use this REST endpoint to push some data up, formatted with JSON up into the cloud, and I'm just going to keep doing that. And eventually what you find out is as you increase the frequency of messages, you potentially increase the complexity and size of data, you increase the number of devices, and you increase the geo scale, that starts to fall short in terms of your needs for data ingestion. You really need a highly scalable solution once you want to go from prototype to some real-world production. Talk a lot about machine learning in IoT, and it's in many ways one of kind of the darling spaces of IoT. And it's a real thing. Like, we see a lot of interesting applications of machine learning. We talk about kind of the notion of predictive maintenance. This idea that most of us have been trained in terms of machine maintenance, that maintenance occurs based on either a frequency of time or an amount of usage. So, change your oil every X kilometers, or do this maintenance every month. The reality is that machines don't work that way. Machines don't operate on this temporal notion of maintenance. That's just a handy shorthand way to kind of practically be able to do maintenance. Machines actually need to be serviced precisely when they need to be serviced, right? And how do you know when a machine needs to be serviced? Well, we see a lot of customers using machine learning to be able to collect telemetry on device, to understand failure signals and to understand good signals, and to be able to predict device outage. So once you kind of get there, and you've kind of got your data ingestion, you've got your BI tools, you've got your storage, you kind of want to do analytics in a real world sort of way by somebody who's not a computer scientist, by somebody who's a specialist in a domain. They want to be able to analyze data and be able to use it and leverage it. And finally, there's infrastructure. What I find interesting is that everybody in this room works in a company that has some kind of infrastructure. Your infrastructure could be some cloud server stuff. Your infrastructure could be power. Your infrastructure could be agriculture. Lots of things that your infrastructure can be. But I think everybody's here because everybody realizes, hey, there are some other partners out there that I want to go find that have some infrastructure that is complementary to my infrastructure that I need to go partner with in order to build a complete IoT solution. And so I'd like to kind of move to a quick little demo to show you how I can build an IoT solution that exhibits these properties of devices and analytics and infrastructure. What I've done here is we've got a little device we built. So I've got a device set up here. I've got a little Surface laptop here. I want to show you this device. So one of the things this device speaks to is it's a great it speaks to the need to be able to use maker-type tools to prototype real-world types of things. So here what I have is I've got a Raspberry Pi 2 computer board here. This Raspberry Pi 2 is connected to a battery, has a Wi-Fi dongle, so it's able to connect to the local Wi-Fi. And here I have a SparkFun weather shield. It's able to give me temperature and pressure and humidity and elevation. And I can read those signals from the device over the I2C bus. This is in a nice little 3D printed case. Props to my team for being able to do kind of this awesome 3D printed case. It's the kind of thing that you could imagine you would close, runs on battery, maybe months at a time. I could stick that on a pole, and it would be the thing that would measure, measure weather characteristics in a particular space. So I've got this device, and if we can now go to the output of the Raspberry Pi, and I'll show you that. So I've got one of these devices running right here on this table, and what you see here is the output of that device. And you can see the readings that are coming on the left. You can see some data that's coming over on the device. And what's interesting about this app, my Raspberry Pi is just running Windows 10, the IoT Core version of Windows 10. And this application is just a Windows 10 universal application. So let me switch now to the Surface. So here you see the Surface. This is Visual Studio. We could spend the remainder of our time together here doing some C++ coding, if that works. Probably doesn't work for everybody, so we'll do something different instead. I want to show you the Visual Studio project and kind of land the point with you that I only have one project. I've built one project that is my source code that I can deploy equally easily to a Raspberry Pi or to a PC, or I have a Windows phone on my desk, and I can deploy the same exact application to all these devices. Not share libraries or a little bit of code, the same exact application. And I'll switch over. Let me show you. Now, you're looking at the same application running on my PC. In this case, because my PC doesn't have the weather shield connected to it, it's finding the Raspberry Pi on my network, and it's reading the values out of the Raspberry Pi, which does have this device connected to it. So this is great. I'm able to kind of gather this data locally as I would for a weather station. Of course, I have HDMI out on my Raspberry Pi, but in the real world where I have this strapped to a tree somewhere, I'm not going to be able to read that kind of data. Using a monitor that I'm going to plug in and hang up on a tree, I want to be able to maybe do that remotely and probably connect that to some infrastructure in the cloud. And so let me take you over to a web page. So what I've got here is I'm ingesting the data that my Raspberry Pi is generating. I'm using an open source library that we've created called Connect the Dots. And what Connect the Dots does for me is it stands up all of the Azure infrastructure that I need to stand up in order to build an IoT solution. Event ingestion, real-time data processing, event storage. I can hook up ML. I can hook up the BI tools, all those things to it. And so this is just my think of it as my endpoint, my front door for my Azure instance that's ingesting this data. If I go over to Power BI, you can see in Power BI that this is another view on the data that my Raspberry Pi here is generating. And this is real-time data. So if I were to refresh, hit refresh on my chart here, you can see it takes a moment, and then the charts will redraw themselves. And I've got new, fresh data that's coming in all the time. Now, Power BI is a great tool that me as a BI power user can kind of get to. I can do rich analytics. I can do rich visualizations. For example, one of the things that we've been able to do is because I have my data in the cloud, I can mix it up with public data sets like airport flight delay information. And what if I want to correlate airport flight delay information with weather? Say I've set up these weather stations at airports across the West Coast. This would be the kind of visualization that I would produce there. And so I'm looking at like flight data that comes from the public data set, mixing this up with my own data set, and getting it in a visualization that makes sense to really kind of deliver a business impact. What I find interesting about this chart is San Francisco has more delays due to weather than Seattle does, go figure. I think San Francisco is more often foggy than Seattle is rainy, but that's just my theory. And then we'll switch back to the slides. There we go. And so, of course, getting to the moon is part of the mission. The other part of the mission is not to leave some people stranded on a rock and actually bring them back home at the end of the mission. And so one of the things I'd like to leave you with is, there we go, that across all of the dimensions that we talked about, across devices, across analytics, across infrastructure, we'd like to partner with you. We think between Windows and Azure, we're able to kind of take care of a variety of the needs to building out an industrial scale IoT solution. Whether you're building devices, whether you're connecting Windows or non-Windows devices to an IoT solution in the cloud. And if you need a global infrastructure partner to be able to deliver reliably elastic compute resources in the cloud or storage resources in the cloud to deliver an IoT solution, we'd love to be there for you. And with that, I thank you for your time.